Differentiating any function that has negative indices in it is really quite straightforward. It follows all the same rules as the ones we've already learned. So you take your power, you bring it down the front, and you reduce the power by 1. So if we look at some examples here to see how it's done, I've written them deliberately in 2 different ways. This is our new notation, which tells us that we're going to differentiate whatever is in the brackets. So if they've asked you to differentiate what's in the brackets, you can just write equals and then write the answer to that differentiation. So taking the negative 3, bringing it down the front and multiplying it by the 4, I get negative 12. And then I need to write x not to the power of negative 3, I need to take 1 off that, which becomes negative 4. Make sure you don't go the other way and write negative 2. In the second example, I've written it another way. If y equals 3x to the power of minus 5, find dy dx. Now, because it's asked me to find dy dx, I need to start by writing dy dx equals. I can't just write equals because then it's very unclear what it's equal to. So dy dx equals, now I take my minus 5, bring it down the front, multiply it by the 3 to get negative 15. And then instead of writing x to the power of minus 5, I take 1 off the minus 5 and I write minus 6. Really straightforward. Now, when you have powers of x that are in a denominator of a fraction, you need to rewrite them as negative indices first. So this is mostly how you'll get your questions, because this is really quite straightforward. They'll generally ask you questions like this. So, if we are differentiating 1 over x squared, we want to rewrite it first. Now, we're not doing the differentiation yet until we've fiddled with the function and got it looking a little bit more like something that we want. So what I'm going to write here as my first part of my working is I'm going to write that I need to differentiate, and then in brackets I'm going to change what they've given me. I need to write this because I haven't yet differentiated it. I'm just changing it. Now this is the same as x to the power of negative 2, isn't it? I just bring the x squared up top and change the sign on the power. Now I can differentiate that just like I could differentiate these ones and say that equals, and probably if I had more space I'd put 1 equal sign on each line and write it down there, but my setting out hasn't allowed that. So I take my minus 2 down the front and I change the x to the minus 2 into x to the minus 3. Now you've got a choice. You can leave your answer like that, it's perfectly acceptable, or you can put it back into the sort of form of what you were given. So this is equal to minus 2 up the top of a fraction and x cubed down the bottom of a fraction. Just be careful, because if you're changing it to something different and you make a mistake in that step, it will be quite annoying because you already had an answer here that was perfectly acceptable. Sometimes that's handy to be able to do this because there'll be a reason that we need to help us factorise or something like that. Okay, the next one I've written it in a different form just so we get used to all the different notation. If f of x equals this, find f dash x. Okay, now I'm not ready to differentiate yet. First I need to write the function with negative indices in it. So the first thing I'm going to write, I'm going to rewrite f of x and change it into a form that I want. Now, the only thing that's raised to the power of 5 here is the x, not the 3. So the 3 actually needs to stay down the bottom of the fraction. And I've got 2 choices. I can leave it as a third at the front and then put x to the power of minus 5. Or I could have actually put x to the power of minus 5 over 3. Now don't write both of these, I'm just showing you could do one or the other, they're the same thing really. Now I'm ready to differentiate, so I can write f dash x, which will be the derivative, and all I need to do is bring the minus 5 down the front and multiply it by a third, which will give me minus 5 thirds, and then change x to the power of minus 5 to minus 6. And if I want to, I could even rewrite that and bring the x to the power of minus 6 down the bottom of my fraction. So I've got minus 5 over 3x to the power of 6. But just be careful in that step in case you mess that up and you don't want to spoil your answer.